I truly want to thank everybody for coming to this webinar. I put it together couple months ago and started to uh, send everything out, working with my partners over in BC, a nice Canadian company, Turnium, with Roger and Logan. They'll be giving you the demo that's coming up. Here at Netview Consultants, we're a partner of theirs, and we're doing the SD-WAN portion. Roger, can you push it forward one more? All right, so at Netview, what we do, we're doing SD-WAN. We do everything that comes up with it, right? So with SD-WAN, we have the internet connectivity. We offer voice services. We can give you the MPLS or broadband connections that you need. Along with that, we also have the security and managed services that we do for customers across the country. So it's everything that we do is geared towards getting the customers up and running, right? So we all remember back in the days how your old network used to look. Everybody had MPLS connections. They took like 6 months to get installed. They're high quality, they're very reliable, but those lead times were terrible. It's very expensive, and if you had a site that you wanted to get up, it definitely wasn't something that was going to happen really fast. I know supporting these networks, when you had something going out of your infrastructure, you could not see what was happening outside of your network. So you didn't have any visibility going through that network. And the big thing is these lines are expensive, and a lot of times they may have a dial-up line or a wireless line, a second line in there for backup, which is not being used at all, right? Everything's going back to your data center where most of your applications go. Nowadays, push forward, everything is going to the WAN, or going to the cloud. And because it's going to the cloud, we have to make sure that everything is just like how it was when it was all local to you. With SD-WAN, with Turnium, we can do that. We can offer you the type of visibility and control that you did not have before. We can give you that application guarantee, so that you get the application performance for applications that are running in the cloud. You get greater agility because you can get a couple of broadband lines, 3, 4, 20 of them if you want. You can bond them together, and then you have that failover, that reliability of that connection to the internet. And it comes at a cheaper price, so you can get higher performance, better bandwidth for a cheaper price. So that big savings, where it will pay for itself within a year, depending on how many MPLS lines you move over, or you can use it with the MPLS line and something else. It all depends on what you are comfortable with, right? So what I'm going to do is that right now, this is just the start. I'm handing it over to Roger and Logan so that we can get a good understanding of this packet-based SD-WAN solution from our friends in BC at Turnium. Roger.
Awesome. Thanks, Mike. That's awesome. I always start off, this is my favorite way to intro Roger. Roger, beam yourself up, will you? There he is. I love seeing that. That's just us having some fun. Guys, thank you very much for the opportunity to talk to everyone today and be able to showcase our SD-WAN platform. A couple of things I'll just mention before we get started. You may notice, or you may have a thought going through this webinar and through our presentation, that it's so simple. It can't be this simple. It's oversimplified. And you're right, it is. Our big focus is to simplify networks, make it easier to manage. They don't have to be complex, but we want to take those networks, we want to simplify them and improve the quality of your WAN or of your customer's WAN. So today we're going to have 3 components for Roger and I. First off, we are going to focus on customer architecture and deployment strategies, understanding how the data flows work, how our SD-WAN platform can be deployed in your environments. Secondly, we're going to showcase some of the monitoring aspects. We're going to jump into the GUI and show how you can get full visibility into the health of your organization's WAN. Finally, we're going to do a demonstration of the technology live in action. This is my favorite part, where we're going to aggregate multiple WAN links. These are best ever connections. It's a real world scenario. This is not a lab. So there may be issues in it, and we're going to show you that, and there may be challenges. And That's the whole point. There's no point in us doing a demo from a lab. You don't run your businesses from a lab, okay? We're going to aggregate a couple of links. We're going to have an LTE sitting in failover. And what we're going to do is we're going to kill those links. We're going to kill the wire lines, and we're going to fail over the LTE. During that whole time, we're running a video, we're running audio over that exact connection. And it hasn't happened yet, but if we fail, we'll say bye-bye to Roger because he's all behind that environment. So Roger, let's get started. Let's talk about architecture. So why Turnium? We are a true cloud-native SD-WAN piece. Yes, we can provide you with hardware, but we don't have to. We can sit inside a VM on your edge. We can sit inside a VM in a public cloud environment. We can provide hardware. We run on any x86 device. We provide you business continuity. We give the best uptime, in our opinion. We give you the best ROI on your bandwidth. We provide additional layers of security to the transport of your data. And as Mike was mentioning earlier, it's a very flexible product. So you can change what type of circuits you're using based on your requirements. We can play with your MPLS. We can replace your MPLS. There are a lot of things that you can do to really build and, I guess, experience the network that you want to. So next slide, Roger. First thing we're going to talk about is the tunnel. The tunnel is a very important piece, and Roger's going to be my artist extraordinaire here. The way our technology works is from a customer's WAN edge back to our SD-WAN cloud. We're going to build a virtual tunnel over top of multiple WAN links, okay? This could be fiber, DSL, coax, point-to-point wireless. We can play with certain satellite connections. It can be LTE, whatever flavor you want to do, okay? You're going to have those WAN links plugged into a WAN edge device. Again, this could be bare metal. This could be a virtual appliance. Now, your data stream is going to come in from the LAN. It'll hit the WAN edge. We'll break that data stream up into packets and disassemble it. Effectively spray the packets across the different circuits based on the health in real time of those circuits. We're then going to piece that data, all those packets back together into a single data stream in the cloud and send it to its destination, whether that's the internet, some sort of hosted application in your data center, another site of your organization, what have you, okay? Now, this tunnel does a number of things, okay? First and foremost, we aggregate your bandwidth to 90 to 95% efficiency of the bandwidth that's available. So if you have 10 megs, 10 megs, and 10 megs, your customer or you will realize a 27 meg pipe coming out the other side. Also, your IP address that you realize will now be attached to the WAN edge device and not the circuits. This allows you to have consistent uptime and greater than 5 nines uptime, depending on the type of circuits you're using, because now it doesn't matter if one of the circuits is up or down, your IP address isn't changing. And as long as there's one circuit available for data to go down, you're going to maintain all of those sessions that you're using and all of those applications that you're accessing. Next thing that it does is it has packet-based prioritization and quality of service. And so that your high priority applications such as voice, video calls, what have you, are going through. And Kathy in the back watching cat videos on YouTube isn't congesting your network, okay? The final piece of what this tunnel does that I'm going to highlight is an additional layer of security through obfuscation. So if you think about it, if someone was nefarious and smart enough to be able to tap into one of the circuits at your site, let's call it Telus' circuit, for example. And then, first of all, they got to be smart enough to do that. Then, if they're smart enough to do that, then they're going to have to crack an AES 128 or a 256 encryption protocol that the handshake is actually refreshed every hour on the hour. If they can also do that, they're going to have to crack our proprietary algorithm that disassembles and reassembles the packets that make up and creates that tunnel. And if they're smart enough to do all of this, then they have stolen 1/nth of that data stream, n being the number of circuits you have at your site, rendering the data they've stolen completely useless anyways. So it adds a whole nother layer of security through the transport of data. So that's the tunnel. I highlighted it here. It's going to be highlighted through the rest of the slide deck here simply by 2 red lines leaving customer sites. But I wanted to make sure that we highlighted that here. Next slide, Roger, if you please. What you can also do okay, is if you want, you can bypass the tunnel. So you can identify specific traffic that you don't want in your corporate network. And we can simply exit from the WAN edge directly from the site and bypass the tunnel completely. So things like if you don't want customer Wi-Fi in your corporate network, you can have that exit. So again, define the type of traffic you want in or out of your corporate network. Next slide, Roger. So now we're going to start talking about deployments. And again, this is very simple, but I think it's very important to cover, okay? We talked about the features of the tunnel, 90% link aggregation efficiency, same IP on the failover, bidirectional QoS, advanced data transport. Oh, maybe I didn't mention earlier. Everything that we talked about in that tunnel happens bidirectionally. It's not just leaving the site. It's both in and out. So in this example is a very typical deployment for a single site customer. You have a WAN edge device, okay, that hands off to a firewall, that hands off to the LAN. Very traditional for any type of internet circuit deployment for any user. But now what we can do, if we start talking about multiple sites, as Roger goes to the next slide. Okay, so let's say you want something similar to how a lot of MPLS deployments are structured, where there's a single firewall at your corporate head office, and the branch sites come back through the corporate head office to have their ingress or egress point to the internet. We can do that and support that with SD-WAN. What SD-WAN now also allows you to do, however, and I'm talking a little too fast for Roger's penmanship, but what we can also do is take all of that traffic. We can host your firewall in the Turnium cloud, or we can put an aggregation server into your cloud, okay? And what this allows you to do is have a central managed firewall. So now your ingress and your egress is through a cloud or data center environment and not chewing up all that additional bandwidth at your corporate head office. Again, highlighting very flexible ways to deploy this. One thing I'll highlight quickly before we go on to the next slide. We do not believe that SD-WAN was created to be a firewall feature. It was created to be an MPLS replacement originally. Okay, we've chosen, made a very conscious choice to remain firewall agnostic, so we can play well with any of your firewall options. A WatchGuard, a Cisco, a Palo Alto, Fortinet, what have you. We remain agnostic to that. Simply because let's do what we do let's do what we do great, and that's the network. We're going to let those guys do what they do very well, and that's security. Most major enterprises I talked to that deployed SD-WAN that even have firewall features built into it kept their firewalls for security purposes. So we'll let the firewalls handle the firewall functionality. Next slide, Roger. Okay, there's a lot of organizations now with public cloud strategies. They could have single public cloud strategies. They may have multiple public cloud strategies. What we're able to do now is by dropping a virtual instance of a WAN edge device right into an Azure environment or IBM SoftLayer or AWS, we can now treat those public cloud assets that you rent or you have infrastructure service or hosted applications in. We can treat those just like they're any site of your organization through our private wide area network. Okay, giving you the ability to securely and reliably connect to those applications without the need of very expensive MPLS direct connect type connections. Next slide, Roger. And I'm going to hand off to Roger on this one so I can get a break and have a sip of water here. But Roger's going to highlight a couple of things when it comes to MPLS. We can build hybrid MPLS networks. We can help offset or replace MPLS networks. We can help you transition off of MPLS networks. It's really what your goals are for your network. But Roger, I'm going to hand off to you for a second. And Roger, you're on mute.
I'm on mute. Thank you very much, Logan. So on this slide, as Logan has said, we can support a number of different things. So let's start off with the most obvious, and that is MPLS networks that don't have reach to all of the sites. Now, because you're able to use public internet and create an SD-WAN infrastructure over that, you can now extend that MPLS network with the use of the SD-WAN core. In some cases, that's pretty much the only option. Some people will have MPLS and will want to keep their MPLS, but they do want some of their sites. They want a lower cost at some of those sites. So now what we can do is we can build a hybrid. Building a hybrid is really great because building the hybrid is the next step to actually eliminating that MPLS network completely. And we have seen this done numerous times. One of our customers here in Canada of the Turnium solution, a very large countrywide law firm, had an MPLS network, and of course their contracts all expired at different times. We created a hybrid network for them, and then as time went on, their MPLS was converted over, and now they are running completely on an SD-WAN environment. They have dropped their overall spend per month drastically, and they have improved their performance. And actually improved their performance so much that when they actually got switched over at one of their sites, which was their disaster recovery, they called us and said, oh, we have a problem. We're going to have to can this and move back. And so our techs looked at things and said, well, we don't understand why. Everything's working perfectly. And the response was, well, every morning when we come in, our backup is still running. And this morning, our backup wasn't running, so it must have broke. And so our techs asked them to take a look and confirm that their backup was indeed completed or not. And of course, they came back all kind of sheepishly and said, oh, yeah, everything's okay. We're good. The backup was completed first time ever. It's actually done that before we got in. Logan, back to you.
Thanks, buddy. Yeah, that was actually a pretty funny situation. They were actually pretty irate at first. Like, we put this in and it broke. I'm like, oh, wait. No, it didn't. It's just never finished before. Roger, if you want to go to the next slide. So that's the deployment strategies. Today, so in the demo, once we get to that portion, like I said, we're going to show bandwidth performance, continuity, and quality of service. But first, let's get into some monitoring and management. Let's show you what kind of capabilities and reporting you have into the WAN health of your organization. As Roger switches gears. Oh, okay. Before we get into the, okay.
Yeah, I can get back into that real quick because it's actually good for them to see this.
Yeah. So we will get to the monitoring management in just a moment. Before we do that, just a quick visual on what you're going to see on the demo. So we have two virtual fibers. These are shared connections and best effort connections that are plugged into a WAN edge device. We also have a Rogers LTE circuit. What you will see in the demo is we'll aggregate the fibers, then cut them. The LTE will go from passive to active, or what I like to call 0 to hero, in under 300 milliseconds. Now, behind that WAN edge device is Roger's VoIP phone. Behind Roger's VoIP phone is his computer. So like I said earlier, we haven't failed it yet, but if this doesn't work, we're going to say bye-bye to Roger. So hopefully that doesn't happen. That's Roger's pet dragon, Boris, okay? And now we're going to get into the reporting. So this is the interface that you would see upon login. You would be able to see any of the sites in your organization for health of what's going on. You'd be able to see what kind of downtime we prevented you over the last week or month. You'll also be able to look into the health of the circuits. As you can see, YYZ test bond is down. Well, that's because we have it down. It's a test bond and we're not using it right now. However, the USS Endurance, which is the Starship Roger's flying on in just north of Toronto, has two circuits. And again, those are the two virtual fibers and the Rogers LTE we talked about. Okay, Roger, can you jump into the USS Endurance for me? So let's look at this. So never before, really, has an organization been able to see into the health of the internet circuits they're paying for. That's something most major telcos have kind of kept for themselves, and I understand why. So now you can actually go in and see how these WAN circuits are performing for you. You can see if you're using any QoS with us. Leg state changes identifies if circuits were up or down. You can see how much packet loss you have on each circuit, on the ingress or on the egress. Well, there's not a whole lot of packet loss going on right there. Let's go up a little further. You can see the latency on each of the circuits, again, on the ingress or the egress. Okay? All of this reporting that you've never really had insight into your sites for, you now have access to. You can see how much data is through the tunnel. You can see the latency on the tunnel. So again, tunnel or circuit itself, there's a lot of reporting you get. Remember, I said we focus on creating a healthier WAN. understanding what's going on your WAN is part of that. So as we continue to go up, you can see who has made any changes or updates to any sites and what those updates were. And now we're going to see the circuits that we're using. So again, we have 2 virtual fiber connections. They're rate shaped to 40 by 10. However, because it's COVID and because this is going on in Roger's basement, aka the USS Endurance, guess what? There's kids right now in school. They're on Zoom calls or playing Fortnite, depending on how productive the kids are right now.
Or both.
Or Roger's kids. Or both at the same time. They're chewing up some of the bandwidth. So we have them rate shaped at 40 by 10. We'll see what kind of performance we're getting out of that, but we're still going to aggregate that to 90 to 95% efficiency. You're going to see that the LTE failover is in failover mode. This means no data is going to pass through that circuit unless the other 2 were to die. We know in Canada, LTE is very cheap to have, very expensive if you use it. So we want to keep those bills low unless you need it to be alive. Now, bandwidth adaptation, I'm going to highlight something. One thing that a lot of businesses realized pre-COVID, but everyone is realizing during COVID, is network congestion. The effects network congestion have is an increase of packet loss, jitter, latency. What it means for a business is gargly phone calls. What it means for a business is lagging on download or performance on web applications. What bandwidth adaptation does is it helps mitigate the effects of that. And Roger, I'm going to get you to dive in and just explain exactly how that works.
Sure. What I've done here is I've actually come into where we set up bandwidth adaptation. And bandwidth adaptation can be turned on and off by simply flipping the switch. And so there we have it turned on. There are a number of capabilities or numbers now that we can check here. And the first one is the packet loss that I'm going to highlight, and that's set at 0.5%. And what this actually does is this triggers the bandwidth adaptation to kick in. So if we see 0.5% latency, jitter, and or packet loss on the circuits, the system will now automatically slow the circuits down. Now, we don't really do anything monitoring wise until we get to 90%. So if this circuit gets slowed down to 90% or greater of what it is capable of, we're going to send out a warning. That warning really is this status that you can see here on the left-hand side, and that icon there is going to change. Let's get back in there. Those warnings now can, through the API, be sent off to maybe your network management system or other systems. We also have a limit threshold. I've got this set at 40%. This circuit that is set for bandwidth adaptation will never slow it down any more than 40% of what it's capable of. I could make that 60 if I wanted to, just by changing the numbers. And now we'll slow it down to 60% of what it is capable of. There's also a packet loss threshold, and this is where we the removal threshold is at 5%. If we get a circuit that has 5% packet loss, latency, and or jitter on it, there's no sense in having this in the bond. So what happens here is it is removed from the bond. The system will test that circuit and only put it back into the bond when the packet loss or the other capabilities here are back within the parameters that we have set. When you're done, you click on save. I'm just going to click on cancel.
That's awesome. Thanks, Roger. Next, Roger, if we can actually go up, I just want to show something as simple as PWAN and the drop down in PWAN. Because I think, again, talking about simplicity in here is very important. So we have a thing called spaces. And when we create a new private wide area network for an organization, we create a new space for them. And if anybody here has ever configured a meshed VPN before to connect your sites, it can be very cumbersome. It can be a lot to manage. And really, what I'd like Roger to highlight quickly for us is how simple it is once you've got a profile in here that you can simply create all of the mesh and connectivity essentially between your sites with a dropdown. So Roger, if you want to take over and just walk us through what you're doing here.
Sure. So what I did there is I actually just created a new space for the ABC co, and it was actually that simple. Just create the space. From there, you want to create the private WAN. We enable private WAN, and in this case, we're going to do it as a managed mesh. What the managed mesh says is that we're automatically going to connect all of the sites through BGP back to the aggregators, and the aggregators will create a managed mesh between them all. So it won't matter what aggregator the site is connected to, it will be able to connect to any other site within this private WAN. From there, I just have to click on save. And now as I create the bond profiles, I enable them by placing them into this private WAN. And while I'm doing that, add them to the private WAN or enabling them within private WAN, and it's done. So it really is that easy to actually build. One of our partners that we showed this to was quite upset with us. And his comment was, when he first saw this, "You mean to tell me that you could have saved me 3 weeks of work while I had to touch each and every firewall at 50 sites to create all the routes for all 50 of those sites?" And we said, yes. And we could see tears running down his face on the video stream that we were watching, because he couldn't believe how easy this was.
That's awesome. Thanks, buddy. Next thing, Roger, if you can we jump into quality of service quickly here? So one of the really nice things about our QoS engine is it's an elastic-based quality of service. And what that means is that there's no hard caps set or reserved for each of the each of the classes. However, so for example, real time, let's say you've got your voice in there, your video conferencing in there, your Office 365, what have you. So here we have it set at 40%, meaning if it needs it, real time class of service will reserve up to 40% of your total bandwidth. However, if it doesn't need it, the remaining classes can borrow from that pool. Okay, so it makes you, again, able to really realize and utilize all of that bandwidth at your site. How we tag everything into a class of service are with packet filters. One of the cool things about this is you can have your QoS profile work however you want to. And so there was a situation with a partner where they were servicing some of their customers actually in Muskoka. And one of the requests that they had at Cottage Country was, we don't care about VoIP. We want Netflix to work. And so what they did is they flipped QoS on its head and made VoIP the last priority and Netflix and streaming services the top priority. So there's a lot of cool stuff that you can do with this, really based on whatever your requirements are. You can choose what applications go into or what type of data goes into each of those classes. Roger, do you want to talk about the packet filters? Because that's really how we identify things into those classes.
Sure. So we utilize these packet filters to identify the traffic that is going to be placed into the different classes of service. So just going to highlight a couple of them here. So we have IAX2, SIP control and TCP and UDP, H323 control, as well as a DSCP tag that we can actually mark that data. So we can identify it by protocol, the length of the data stream, the source or the destination of the data stream, ports, and so on. Basically, layers 3 through 5 can be done here. Now, one of the things you'll see is real-time here, ICMP, but that ICMP actually has to have a length of 500 milliseconds. Now, I've done that on purpose here because I am going to be starting in a few minutes a ping test or an ICMP test whose length will be longer than 500 milliseconds to show you a visual phone call. And so we wanted that moved up into real time. The other thing that we're going to be doing is we're going to be doing a bulk download, and it's an HTTPS flow greater than 2 megs. And so what we've done to make sure that that is going to hit bulk traffic is we have created a packet filter here that says an HTTP flow of greater than 2 meg will be placed in bulk traffic. And as a result, you will see that bulk traffic go from a few minutes to over 2 hours in order to complete as we go through the demo. But basically, you set up the type of data that you want here in your packet filters, and that data then hits its appropriate class of service.
Thanks, Roger. We'll tell you what, you're just talking about that demo and the files you're going to be doing. So why don't we hop into that and show these people exactly how the platform works and what type of functionality they can have access to. So what you guys see here is Roger's logged into his WAN Edge device that is sitting on at his site. I'm going to give you a little tour of what's happening on screen here. First things first, top putty window in the top right. ENP5 and ENP6 are those two virtual fiber connections we showed you earlier. Now, not a lot's going on right now. You'll see the bandwidth increase here in a second. ENP4 is the LTE. The LTE, you will see a little ping piece of data being sent through that. The reason we want to do that, it's a heartbeat check. Last thing you want to have happen is your backup link dies when you're not using it and you don't know about it. So we want to make sure we're monitoring that. Roger's about to start a ping test in the middle window, which is going to represent a visual representation of a voice call, tiny little packets being sent. And what I'd like you to pay attention to right now is watch in the top window. You're going to see the bandwidth as soon as Roger starts that download. The bandwidth on both ENP5 and 6 are going to increase at the exact same time, proving packet-based load balancing and also showing that we are able to utilize all of that bandwidth. So Roger, start that download for us. Let's watch the bandwidth go up. Oh, there, I already did it while I was talking. Look at you. Now, you see the downloads running. Bottom left corner, there's about 6 minutes left. That'll be important in a minute. Roger's about to start dropping these circuits. So you will see ENP5 and ENP6's bandwidth drop out. Once he gets to the second, once he drops ENP5 first, once he drops ENP6, you will watch the LTE circuit now carry the entire load. When he's doing that, he's going to be talking. I want you to pay special attention to his voice. See if you can hear the cutover. See if you can notice when that circuit fails, and see if you can notice any anomalies in his voice. Once he's done that, then I'd like you to look down at the bottom left and see how much time's remaining on our download. Roger, I'm going to go on mute. Take it away and walk us through what you're doing so we can hear your voice.
Okay, great. Thank you very much, Logan. As you can see here, leg drop 117, that is actually going to be dropping leg 117, which is ENP5. So let's drop that now and take a look and see what happens. You can see there that ENP5 has dropped down to kilobits per second. That's because the system is trying to test that, but you will see it drop now to 0. And every now and again, there'll be a ping test while the system does try and test that. Our download, still 7-8 minutes. We can see that that circuit indeed has failed here in our interface. So let's get ready now to drop leg 116. The ID 116 is that ENP6. Now we're fortunate today, ENP6 and ENP4 are side by side here, are one on top of the other. Remember, ENP4 is our LTE. And as I drop the ENP6 right now, you're going to see that it's going to go down. The system's trying to test it, and immediately ENP4 spun itself up to 3 megabits per second. So right now, we have switched over to the LTE. It switched over hopefully seamlessly. Hopefully I'm still there talking to you. You can see my video. And if we take a look now at the bottom corner here in the left, our download has somewhere between 1 and 2 hours left in running. That is that big HTTPS download, and it has now been moved, or it is running on a very little bit of data, while my phone call and my Zoom meeting are high priority and they are in real-time communications. So let's bring these back, if I can get the right. There we are. We'll bring back 17 first, and then we're going to bring back 16, and we will see our ping test continues. Our download now is back approaching that 8-9 minutes that we had before. Our circuits now have healed. And let's take a look and see what actually happened. What we were doing there in the center with that simulated phone call. So we're going to stop that simulated phone call and take a look. 10,580 packets in that phone call were transmitted, and we received 10,552 packets. So we lost 28 packets, or 0.264% of the packets throughout that. Now, something to remember is the packet loss that you have on a standard phone call. Across that same time period, I can guarantee you that your cell phone will have dropped more than 28 packets. And you don't even notice that. So hopefully you didn't notice any anomalies, or if you did, it was just a slight click within my voice.
Roger, thank you as always. I never get tired of seeing that happen. And I just want to reiterate what just happened. We had 2 virtual fiber connections that were plugged into a WAN edge device and an LTE in standby mode. All the bandwidth was running through these virtual fibers. These fibers died, failed over to an LTE that wasn't doing anything, and then came back. And we maintained Roger's video, we maintained his voice. So again, I go back to simplifying networks and building healthier networks. That's what our focus is. And so if that's something that's important to your business, we'd be happy to talk further. Mike, thank you so much for the opportunity for us to come here and showcase this technology today. I still get giggles out of that demo watching that happen, and the fact that we lost 28 packets while ripping everything apart and healing it, I think is pretty cool. So Mike, I'll hand it over to you, sir.
You guys did a good job, man. Very good, very good. Thank you guys for doing that for me. You know, and I want to thank everybody for coming on the online. I just want to know if anybody has any questions. You know, you can put them in the Q&A. Also, if there is anything that you need to speak with me offline, you know, we can talk about that, and we can give you more detail on how it can work for your organization or organization that you are working with.